Hi, this is Mrs. Barbara. This is Physics Chapter 9, Current Electricity, Video 8. Today's topic is parallel circuit. The objectives are: know the definition of parallel circuit, know the rules for current, voltage, and equivalent resistance for parallel circuit. Understand, a parallel circuit is one with multiple paths, where each resistor has equal access to the battery. They all have the same voltage. Understand, adding resistance to a parallel circuit lowers the overall resistance because it allows electrons to follow even more paths. This increases the current and therefore causes more strain on the power source. Be able to sketch or select diagrams of parallel circuits, including proper placement of meters. Use the VIR chart. That's the one we did before. It's voltage, current, and resistance chart. And the Ohm's law. Don't forget Ohm's law to solve parallel circuit problems. Be able to determine the power or electrical energy used by circuit components or an entire circuit. Use the junction rule to determine the unknown current and determine the effect of adding or removing resistors to the rest of the circuit. Definition of parallel circuit says a circuit in which there is more than one way for the current to flow. For example, here is the battery right over here. When the current comes over here, it can come to 30 ohms or it can keep going. So there's more than one way for the current to flow. So here are the three things. More current flows through smaller resistor. Remember, this is different from the series circuit. For series circuit, all the current are the same. So more voltage drop will across the bigger resistor and less voltage drop across smaller resistor. Over here it says more current flows through small resistor. The potential difference is the same. So for series, the current is the same. For parallel, potential difference is the same. They all have the same drop. And again, it's the same thing. By the time each charge makes it back to the battery, they should have lost all their energy given by the battery and needs to be re-energized again. Here are the rules for parallel circuits. So equivalent resistance is 1 over R equivalent, or the same as 1 over R total equals 1 over R1 plus 1 over R2 and so forth. By the way, all these equations are in your reference table. Next one is current. Current adds up. I equals I1 plus I2. And voltage, all voltage are the same. So all the circuit components and the circuit as a whole must obey Ohm's law, which is I equals V over R. And R equals V over I, and V equals I times R for each single component and for the total. Here is the junction rule. Junction rule kind of applies to the current. Current equals I1 plus I2, and so forth. What the junction rule says the total current flowing into and out of junction must be the same. So whatever comes into this junction is a two cross. It's like crossroad, right? Whatever in here is the same as the current getting out of here. Let's take a look. If you have 10 amps comes in and goes out this way, goes down, has 4, what has to be the current going to the right? It has to be 6 according to the junction rule. Let's do an example. So the diagram shows the current in 3 of the branches of a direct current electric circuit. The current in the 4th branch between P and W must be what? Let's see. Here is the junction. Junction is P. The one comes into the junction is 3 and 4. So total coming in is 7. Total going out is 6. We said in has to be equals to out. So the current in the 4th branch, P and W, has to be 1 amps going toward the W. Next one, let's take a look at equivalent resistance. Equivalent resistance of circuit is the amount of resistance which a single resistor would need in order to equal the overall effect of the collection of resistors. That means we can replace every single resistor with one resistor. That's the resistance of that resistor is called equivalent resistance. For parallel circuit, the mathematical formula for computing the equivalent resistance is this: 1 over R equivalent, or R total, equals 1 over R1 plus 1 over R2 plus 1 over R3, and just keep adding, where R1, R2, R3 are the resistance values of the individual resistor that connect in parallel. So for series circuits, more resistors means less resistance. The more you add, less you have. For parallel circuit, adding more resistors, you add less resistance. So take a look. If you just have 4 ohms, your total resistance is 4. But if you connect 2 4s parallel, this is parallel because the current come to what end has 2 ways to go. So 4 and 4 are parallel. Your total resistance is just 2. How did I get 2? It's 1/4 plus 1/4. That's 2/4. Then you have to flip it. So you get 2. So the more you add, the less you have. 6 and 6, your total resistance becomes 3. 12 and 12, your total resistance becomes 6. Okay, equivalent resistance, if you keep adding, instead of 2 6, you have 3 6. Then your total resistance is even less. So the more resistors you have, the less resistance you have. You add 3 9ths, 1/9 plus 1/9 plus 1/9. That gives you 3 9ths. Then you have to flip it. 9 divided by 3 gives you 3. Here's 1/12 plus 1/12 plus 1/12. That's 3/12. 12 divided by 3 gives you 4. Remember, note the equivalent resistance. Equivalent resistance is less than any single resistance in the circuit. So 2 is less than 4. 3 is less than 6. 6 is less than 12. 2 is less than 6. 3 is less than 9. 4 is less than 12. Let's take a look at this example. Resistors R1, R2 have an equivalent resistance of 6 ohms when connected as shown. What is the resistance R1? So we know total is 6. So equivalent resistance is less than any single resistance. So single ones, R1 or R2, has to be bigger than 6. Out of your multiple choice, only one of them is bigger than 6. So that's the only possible answer, 8. Another example, resistors R1 and R2 have the same resistance. When they are connected together as shown, they have an equivalent resistance of 4. What is the resistance of R1? So to find, here is the equation for equivalent resistance or total resistance. We know it's 1 over 4 equals 1 over R1 plus 1 over R1 because R2 equals to R1. So that equals 2 over R1. So we can solve for R2 is 8. Or R1 equals 8 ohms. So each one is 8 ohms. Note again, the individual resistance, 8 ohms, is bigger than equivalent than 4. Okay, voltage drop for parallel branch. So in parallel circuits, the charge does not pass through every resistor. Rather, it passes through a single resistor. Thus, the entire voltage drop across the resistor must match the battery voltage. So it matters not whether the charge passes through resistor R1, R2, or R3. The voltage drop across the resistor which it chooses to pass through must equal to the voltage of the battery. So put that in equation form, we have this principal voltage of the battery equals V1 plus equals to V2 equals V3. This is kind of like when you go in the water slides, you go up the steps, and then you have 3 paths to choose. So it doesn't matter which path, you'll all come down to the ground. So each drop is the same. Just some drop takes longer than the other drops. So all the drops are the same. So that's what it means. The voltage drop are the same. Let's take a look at this example. So this diagram shows 3 resistors connecting parallel. You need to fill in the chart to find total resistance, the voltage across each resistance, and the current across each resistor. So first, fill in all the resistors. So the equivalent is 10 because it's 130 plus 130 plus 130 equals to 330. Then you have to remember use 30 divided by 3, so you have 10. We also know the equivalent resistance, equivalent voltage, or total voltage is 60. So from here, we can find the total current, which is 60 divided by 10, which is 6. We also know that the voltage for each resistor is the same as the total, so the total we know. From here, we can figure out each single current and the total current. By the 60 divided by 30 give you 2. 6, this is Ohm's law. V divided by R give you I. Then all the I's add together give you 6, or you can use total voltage divided by total resistance give you 6. Another example. So make a table to find an unknown field in the table. So again, here is R1, R2, and R3. To find total R, we use 1 over R1 plus 1 over R2 plus 1 over R3. Then remember to flip it, you have 5.9 ohms. We also know the current going through R3, because this one is only going through R3 is 0.5. So we know the voltage over R3 is 5. Remember, this is parallel circuits, so all the voltage are the same, 5, 5, 5. Then we can figure out the current for each branch. So that's 0.2, 0.1. The equivalent is all this add together, or 5 divided by 5.9, you'll have 0.85 amps. That's a total current. That's it for today. Thanks for watching. See you next time.